In this example, we're being asked to compute the coordinates of the center of gravity for the composite shape below, and we're being told that block 1 has a unit weight of 150 pounds per cubic foot. And so this red block right here, that's block 1, and notice that's a three-dimensional block, okay? It has a unit weight of 150 pounds per cubic foot. So remember, unit weight is kind of like density, but it's weight divided by volume instead of mass divided by volume. So let's take a look at block 1 right now. All right, block 1 has a length and a width of 2 feet and then 3 feet, and then a height of 1 foot. All right, and then block 2 has a different unit weight. Block 2 has a unit weight of 100 pounds per cubic foot, and block 2 is this little green block here that's got a length and a width of 2 feet and 1 feet, and then a height of half a foot. So we see our origin is given to us back here. So we're in a XYZ three-dimensional space. And so we want the center of gravity based on these two blocks right up next to each other, okay? So let's go ahead and tackle this. Under solution, we see that this is a 3D problem. So if we want the coordinates of the centroid, because this is not the centroid, center of gravity, that is, because this is a 3D problem, we know we need x bar, comma, y bar, and comma, z bar, okay? So we need the triple coordinate, okay? Now, just because this is center of gravity, again, mathematically, the mathematical framework, as we've discussed before, is the same as with centroid. So we're going to take the same general approach, but we're going to be working with something physically different than centroid, but it's very similar, and if not the same, mathematically, okay? So if we remember from center of gravity, what do we have? We have x bar equals the sum of x sub I times w sub I, as I goes from 1 to n, divided by the summation of w sub I as I goes from 1 to n. And then we've got y bar is the sum of y sub I, w sub I, as I goes from 1 to n, divided by the sum of w sub I, again, I going from 1 to n. And then z bar, we got a z bar this time, summation z sub I, w sub I, as I goes from 1 to n, all divided by the summation w sub I as I goes from 1 to n. Okay, so we're basing this on weight this time, not just shape, not just area or a line segment, but based on the weight. Now, if you remember from earlier or previous lecture notes and videos, w sub I, that's a weight, and that's equal to the unit weight of a material, so gamma sub I times the volume of that particular piece, okay? So we can rewrite these in terms of gamma and volume, all right? So I'm going to rewrite these. I'm going to say rewrite in terms of gamma, which is unit weight, and volume, all right? So if we rewrite these, we can get x bar equals summation I goes from 1 to n of x sub I, gamma sub I, v sub I, divided by summation I goes from 1 to n of gamma sub I, v sub I. And then similarly, y bar, summation I goes from 1 to n, y sub I, gamma sub I, volume sub I, divided by summation I goes from 1 to n, gamma sub I, v sub I. And then very similarly, z bar, summation I goes from 1 to n, z sub I, gamma sub I, volume sub I, divided by summation of gamma sub I, volume sub I goes from 1 to n. Okay, so now we're ready to go. Now remember, we have some of these already pretty readily available. We were given gamma 1 is 150 pounds per cubic foot, and gamma 2 was 100 pounds per cubic foot. So pounds per cubic foot. So that's one of the terms that's built into these equations. What about the volumes? Can we get these volumes? Well, sure. Yeah, these are just blocks, length times width times height. So if you look at block number 1, what's its volume? Well, it's 2 times 1 times 3. So it's just a block, of course, and we get 6 cubic feet for volume number 1. Keep those units built in there properly. And then what about volume number 2? Again, it's another block, so it's 2 times 1 foot times 0.5 feet. So in that case, it's just 1 cubic foot. 1 cubic foot, okay, for V2. So now we're ready to substitute these values in. How many pieces do we have? We have 2 pieces, obviously, so little n equals 2. So we're ready to go. Now we're going to say x bar equals, and we're going to say x1 gamma 1 v1 plus x2 gamma 2 v2, all divided by gamma 1 times v1 plus gamma 2 times v2. And then similarly, we're going to have y bar is y1 gamma 1 v1 plus y2 gamma 2 v2, all divided by gamma 1 v1 plus gamma 2 v2. Notice those denominators are the same. And then z bar z1 gamma 1 v1 plus z2 gamma 2 v2, all divided by gamma 1 v1 plus gamma 2 v2. Okay, so we can put check marks by everything we know. We know all these gammas and volumes. All right, and check off all these. What we don't know is the coordinates of each of these pieces, okay? So I'm going to refer back to the original drawing. On an assignment, again, it's probably worth it for you to redraw it so you can look more closely at what you have. But I'm just going to refer back to our original drawing to get x1, x2, y1, y2, z1, z2. So let's make a note of that. We're going to say we still need x1, y1, comma, x2, y2, comma, and x3, y3. Okay, so, I forgot my, look at that. I stated all that wrong. Erase that. We need, we need x1, comma, y1, comma, z1. I confused myself. And x2, comma, y2, comma, z2. Okay, that's what we need. We need the x, y, z coordinates of each of these blocks. So make a note here. This is going to be for block 1, and this is block 2. We got 2 blocks, each with an x, y, z coordinate. Okay, so let's look at block 1. Okay, it's a rectangular block. So where is its centroid? Well, in the x direction, it's going to be halfway the distance in the x direction, right? So it's actually over here somewhere. And then it's also halfway the distance in the y direction, and then it's halfway up in the z direction. So it's kind of hard to see, but I'm going to make a note here. I'm going to say x1, comma, y1, comma, z1 for block 1. What does that come out to be? Well, in the x direction, it's half of that x coordinate, so it's 1.5 feet. Oh, did not mean to click out of that. Let's get back. Don't send. There we go. Okay, we're back. All right, so it's 1.5 feet, comma, and then in the y direction, in this direction, where are we? Well, that y coordinate, that y dimension is 2 feet, so it's half of that, so 1 foot. And then the z direction is 1 foot, so it's half of that, 0.5 feet. Okay. What about block 2? We got x2 comma y2 comma z2. And what are the coordinates of block 2? Just look at the green block right now. In the x direction, we have a 2-foot dimension, okay? So is x2 1 foot? No. Is it 2 feet? No. You got to measure it back from the origin. Remember that. You still got to reference the origin. So what is the x coordinate of block 2? Well, it's going to be 3 feet plus half of this distance. So it's 4 feet. Okay. What about the coordinate in the y direction? Well, it's just right. This little total y dimension, 1 foot. So it's just half of that. So that's 0.5 feet. And then what about in the z direction? Well, it has a height of half a foot. So you're just going halfway up, 0.25 feet. Okay. So the one you got to pay real close attention to is x2. Again, it's based on where the origin is. It's the distance from the origin to the centroid in that particular direction. So that's why it's 3 feet plus 2 feet divided by 2, which is 4 feet total. Okay. So now that we have these measurements, now we're ready to substitute these values in here. So let's go ahead and put our values here just so they're easily accessible. So 1.5, 1, and 0.5 for block 1. And then 4, 0.5, and 0.25. Okay, so now we're ready to go. We're going to say x bar is equal to x1 gamma 1 volume 1. So 1.5 feet. Gamma 1 was 150 pounds per cubic foot. And volume V1, what was that? We calculated that earlier, 6 cubic feet. All right. And then plus, Plus x2 gamma 2 volume 2. So plus 4 feet times 100 pounds per cubic foot plus the volume, which is 1 cubic foot. And then all that's divided by 150 pounds per cubic foot times 6 cubic feet plus 100 pounds per cubic feet times 1 cubic foot. So x bar equals, now you gotta punch this in your calculator very carefully. 1.5 times 150 times 6 plus 4 times 100 times 1, and then we're dividing by 150 times 6 plus 100 times 1. So I get 1.75 feet. 1.75 units, final units are feet. Again, it's a location, right? What about y bar? Okay, y bar is going to be equal to, here we are, y1 gamma 1 v1. So we have 1 foot, 150, I'm going to say PCF, that's pounds per cubic foot, times 6 cubic feet plus 0.5 feet times 100 PCF times 1 cubic foot, all divided by 150 PCF times 6 cubic feet plus 100 PCF times 1 cubic foot. So let's do a little bit of rearranging and see what we get. 150 times 6 plus 0.5 times 100, and then divide by 150 times 6 plus 100. So I get 0.95 feet. And then Z bar, same process. going to have 0.5 feet times 150 PCF times 6 cubic feet plus 0.25 feet times 100 PCF times 1 cubic foot, all divided by 150 PCF. Probably would have been easier just to compute this denominator standalone earlier, so we got one number we can just keep referring back to, but that's okay. So Z bar, what do we get? 150 times 0.5 times 6 plus 0.25 times 100 divided by 150 times 6 plus 100. So I get 0.475 feet. Okay? And so my final answer, X bar, comma, Y bar, comma, Z bar, is 1.75 feet, comma, 0.95 feet, comma, 0.475 feet. And that's my answer.